Hello folks, welcome to my channel Java Demystified by SSR. So this time I have come up with a general question which is not related to Java. It is creating your own header files in C. So how to do that? So let's demystify this. I'm going back to my editor. So this is my Sublime editor. Yeah, so here I have a simple program written just to read the name and print it. So in order to do this, I'm actually taking a character array because strings are character arrays in C. So I'm asking the user to enter a name and I'm reading it using this percentages, and there is no ampersand is required because every array every array name represents the base address. So the name of array itself is a pointer. So again, you don't require ampersand operator to be mentioned. Okay, so here I'm using printf and scanf. So these are the two functions I'm using and which are actually part of a header file called stdio.h, the standard input output.h. Okay, so this has been used with the hash include. So anything that starts with the hash include is actually a preprocessor directive. Okay, so this stdio.h contains several functions which are already defined. Just we should know about those function names and we have to use it in our program as per the requirement. So the question here is, can we have our own header files created? Yes, we can actually create our own header files. So what I want to do is, let me first actually run this program and show you what is actually happening. So we are actually reading a name and we are printing it. Okay, so let me compile. So I'm going to my terminal here and let me compile this. Yeah, so this is gcc space test.c hyphen mode t1 actually. So my output I am going to put in t1. So compile successfully and dot slash t1. Then it asks your name. So what's your name? Let's say the name is some ABC and it says your name ABC. So it's working fine. So did I write my printf and scanf definitions? No. So they are available actually from the header file stdio.h. Now what I want to do is I want to write I want to print actually. See here I am printing the name using this printf. So I don't want to use this printf. I want to write a function to print this. I just want to say out of name. Okay, so what is this out actually? So this out is a function which I'm going to write in my own header file. Okay, so when I say out, the function from that header file should get execute and it should actually print whatever the string I want to print actually. Okay, so how to do that? Okay, so let's open a new file actually here, and I just want to write a function, right? So that out function I want to write, and that function to in order to save the time actually I have written over here. Let's see, and I'm copying from here and pasting over there in a new file. So this is my out function I'm going to write. See how I'm going to write actually. So void out. So this out actually returns nothing, but it takes a character array. So a character pointer can point to strings actually, right? A string is a character array. So now whatever the string that was given to out, it is going to print actually. Okay, so how we are going to print that string? So this is the logic. So I have a pointer actually pointing to the base address of that particular character array, and I will be running a while loop. So every time I will check whether the character at that pointer is null. Okay, so if it is not null, then I am going to print value at that particular pointer, and whenever it is null, that means there is no character left. So we will be coming out of this particular while loop by the time my string will get printed. Okay, this is the logic actually. To print a string, using a function. So now I am writing this function out, and since in this function I am using printf, so I require include stdio.h as well, because this printf is actually part of this particular header file. So let me save this. Yeah, so you can actually save this as a C file only. Yeah, so this is my, let's say, test dot okay, so test header dot h. This is my header file, and I'm giving the name as otherwise let us keep a simple name, test1 dot h. Save. So now when you have a header file with a dot h extension, so first you need to compile that. So gcc test1 dot h. Okay, you have written a header file and you are compiling it. So it's compiled successfully. So you cannot run it. In order to run, you require a main method. Okay, but now what I do is I use this particular out in this particular test.c program. Okay, so yeah, so I am using this particular out function, which actually I have defined in this particular test1.h. So now I have to include that header if at all I want to use this particular function. Yeah, hash include. Now you have to specify your own header files with the double quotes. So this is test1.h. Okay, so it is not in angle brackets. When you write angle brackets, it actually checks for that particular header file in the system directory. If it is in double quotes, this particular header file is checked in your current directory. So now test1.h is there in my current directory. Just now I have created it. It's not a system header file. So that's why you have to specify in double quotes. If it's a system thing, you have to specify in angle brackets. Okay, so now I have included it. So now I can straight away use my out. So out of name. So whatever the name that you are reading, that is going to get printed actually. Okay, yeah. Let me save this and let me compile. Yeah, gcc test.c -mode t1. Now it's compiled successfully. There's no problem because out function is available in test1.h and that particular header file has been included already. Okay, so now let me actually check the output. So /t1, it asks me to enter your name. I am actually entering my name as Kwati, and it should display actually. See, I have read through scanf and I am using this out. Okay, so out actually displays a string. So I am passing a string and it should display. Yeah, Kwati has got displayed, right? So if at all you want to separate this output and this particular command line, you can actually have a new line printed here. So I can actually print this particular new line using printf. However, my studio.h is there, so printf I can use whenever I want. So this is the function I have used in my header file of my own actually. Okay, so let me again compile and run this. So compiled successfully, and when I run, enter your name. This time I am using my name as some XYZ. Now let's see. Enter your name XYZ, and XYZ got printed through this particular out, and this out has been defined in my header file. Like that, I can actually write n number of functions which are as part of my test1.h, and I can do that. Now, for example, I want to print the length of the name, whatever I am taking it actually. Okay, how do you find the length of string? Because name is a string here, it's a character array. So we don't have straight away any method unless you use a string.h. So there is a header file called string.h, and in the string.h we have actually string handling functions like string cat, string length, string comparison, etc. I have to use that string strlen, the string length function, which is already there in string.h. But I want to write my own function to find the length actually. Okay, and I want to print the length of the string, something like this. For example, printf, yeah, so the length of name, whatever the name that has been entered, right? The length of percentage s, that percentage s is nothing but the name actually, right? Is now I am going to have this percentage d, then actually a new line is going to get printed. So now percentage s is actually the name that we are actually going to print. So for example, your name is abc, it says length of abc is, so what is the length actually? So now I am going to write a function. Okay, that function itself is length. I'm going to write a length function which is going to return me some integer. That's why percentage is here, and it takes a string as a parameter. So now what should happen? The length of name, whatever you are giving, is the length. So do you have the length function in C? No. So I'm going to write it in my header file. So time being, actually what I did is I had already this function written. Just I will explain you. So this is the function. I am actually putting that in my test1.h file. So this is to find the length of a string. So what we are doing, so the length function will take a string as a parameter. A string is a character array, and character pointers can actually point to the strings in C. So now I have a count variable 0. So what I'm doing, I'm actually finding the length. So as long as the value at that pointer is not null, we are actually going to count. So whenever it becomes null, we will come out with the while loop, and the count value will get returned. So the count value is an integer, so that is going to get returned, and that we are printing as part of the printf statement in my test.c. So this is the logic. So as we know, this star ptr is a pointer pointing to the first character of the string, that is the base address, right? And every time pointer plus plus, so it increments by one character because it's a character array, and every time we are checking the value at that particular pointer. So if it is not null, then we are counting. If it is null, we are coming out and taking the count value. Okay, so let me save this. Because I have modified this test1.h, I have to compile this. So I am going to compile this now again, and I have this written already. So gcc test1.h, so compiled already. Now let me go to my test.c. The test.c, already I have used my length function, and the test1.h is already included. Okay, so just save this, and I just have to run actually. So gcc test.c -t1, yeah, it's compiled successfully because out is available and the length function is also available in test1.h. However, printf and scanf as part of your stdio.h. Okay, so let me run this /t1. So it asks your name, so I'm actually giving Quati. So first Quati will be read and the Quati will be printed, and then as part of this particular statement at 70 number, so we are going to see the length of Quati is so and so. See here, Quati, the length of Quati is 6. Okay, so I'm not using here any string handling functions like a string length, etc. as part of string.h. I am writing my own function as part of my own header file. Okay, yeah. So let me actually add up one more thing. So for example, I just want to print off a factorial of some number. Okay, so printf factorial of um, factorial of some number actually. So that number we can either take, otherwise we can assume directly factorial equals to, and here factorial is actually an integer value. So factorial %d equals to, now I am going to use a function called factorial, and I can pass any value. For example, I want to pass factorial of 7. Okay, so printf factorial of Okay, because I'm using 7, I can say 7 straight away here. 7 equals to %d, and after printing, I just want to give a new line. So I am actually calling a factorial function. So do you have the factorial function written here? No. What I'm going to do is I'm going to write a factorial function and put that into my test1.h. And whenever I actually call factorial, it gives me the factorial value, right? We know how to find a factorial of a given number, right? So time being, I have already written actually. So this is the logic to find a factorial of a given number. So let me put that into my test1.header file. See, like this, you can actually have n number of functions written as part of your header file. So here, I have this factorial function. It returns an integer, it takes a value, and I have a variable declared fact, which is initialized to 1, and I was there. So I am running a for loop from 1 to this particular n, because that's how we calculate the factorial. For example, factorial of 4 is 4 into 3 into 2 into 1. That means you are actually multiplying starting from 1 to that particular number, right? So for I equal to 1, I less than or equal to ni plus plus. So fact equal to fact into I. So initially it is 1 into 1, then 1 into 2, then 2 into 3, then 6 into 4. Like that, the factorial will be computed. So that is actually very known logic, everyone knows. So I have written this function as part of my test1.h, and whenever this factorial is called, it returns a integer. So let me save this and let me compile because I have modified it. So I am compiling this. Yeah, so this is GCC test1.h. So compiled successfully. Now test1.h has 3 functions in it. Okay, so let me go back to my test.c. See here, I am using the factorial straight away. Factorial of 7, which is as part of my test1.h. Let me save this and compile and see whether you are going to get the outcome properly or not. Yeah, so GCC test.c, and the output I'm keeping in T1. So compiled successfully. And when I run, actually, it asks me to enter your name. I can enter my name. So let's say my name is now Hyderabad. Okay, so the length of Hyderabad is 9. Okay, the Hyderabad got printed with the out, and the length has got printed with the length method I have written as part of test1.h. And now if you see, the factorial of 7 is 5040. So this factorial is a function which I have written and put that into my header file, my own header file. So this is how you can actually create your own header files, and you can add up as many functions as possible. Okay, so when you practice, actually you will be writing so many functions to do different things. A function to find a palindrome, a prime number, Armstrong number, function to generate Fibonacci series, etc. and etc. You put them in some header file, you give some name, whenever you want, you just include that header file and call that function, and that's all your problems as part of your requirements. Okay, so yeah, so we can actually uh, elaborate this by adding so many things, and it's been actually some 15 plus minutes. So hope you have understood how to create header files and how to use them, those functions as part of the header files in your program. Okay, so this is not the Java stuff actually. So it's a general question. So I thought this is important because in order to ready for your interviews, you require C, C++, Java, some data structure stuff, and of course, Python, etc. So time by time, I'm actually coming up with some general questions as part of the channel Java Demystified by SSR. So thank you. So if you like this particular um, question, explanation, the answer, you can actually like my videos, you can actually share to your friends, and of course you can actually subscribe if you have not subscribed to my channel. Thank you. See you with more videos. Please stay tuned.